So a while ago, when Netflix still included the delivery service as part of the streaming service, I don't know if any of you remember this. It was like, way back in the old days. Somebody actually hacked my account, and it was really funny because what happened is they didn't change any of the streaming queue, because at that point there wasn't really that much available to stream. But what they did is they replaced everything in my delivery queue with all of Nicolas Cage's filmography. And they didn't update my address, and I was like, this is really, really weird. I don't know what happened. Maybe it was one of my friends that was trying to troll me. More likely it was that somebody had hacked my account and was trying to use it just to watch Netflix. But that was the first time that any of my stuff had ever been owned. And I always remember that story now that I think about passwords all the time, because it's something that happens to a lot of people. And so you might be wondering, what does any of this have to do with Spark and Scala? Well, it turns out that there are a lot of these owned passwords. Owned, by the way, spelled with a P, is the hacker way of spelling owned, but you keep the P silent, and if you do that, just people will think you're cool, so trust me. But so anyway, that was my story about getting owned, and it turns out that there are a lot of these passwords that are available for purchase on the internet. And we're going to be looking at those today using Scala and Spark. Spark is a project that's been around for about 4 years. Back when I worked in ad tech, we were using it to do all of our extract, transform, load, our ETL pipelines. We were using a combination of Spark and Scala to build those projects. And when we got started with Spark, we were on maybe Spark 1.1 back in around 2015. And so it's been really interesting to see how the project has developed since then and see how the different abstractions have gained traction and developed and gained different performance improvements over time. And so this talk today is going to be combining those two stories, how we can use Spark, what we can learn from my experience with Spark, maybe how you can get started analyzing some of your own data, but we're going to be looking at it through the lens of owned passwords. I got out of ad tech about 6 months ago. These days I'm a developer evangelist at Twilio, where I get to work on a lot of fun and interesting things. So for those of you that don't know, Twilio is a communications company. We provide APIs that make it easy for you to add things like text messaging and voice calling into your applications. And you can do this with all of the tools, languages, and frameworks that you already know. A lot of the stuff that I work on has to do with our authentication products. And so back in 2015, Twilio actually acquired Authy. Phone numbers are very closely tied to identity, and Authy is a common two-factor authentication and identity management solution. And so I work on a lot of our account security products there and spend a lot of time thinking about how we can protect our identities online. And in the spirit of security, what I wanted to do with this talk was kind of combine those things, those interests, and look at the idea of passwords. Passwords have really been the way that we've secured our online identities for the last 30 or 40 years. And it's really interesting to see how terrible most people's passwords still are. What happens is companies' sites get breached, and this data becomes available. And so we have about 500 million passwords and credential pairs that are available for download, for doing analysis on, and that's the data that we're going to be looking at today. We're going to start by introducing Apache Spark, look at why people use it, and how the project is developed. I will give a little bit of background on the state of passwords before we dive into the data. Then I'm going to show you what Spark looks like in action, especially some of the newer stuff that's been around in the last year or so. And finally, we'll wrap up by talking about the implications of big data and security. All right, so let's start by looking at the Apache Spark project. So Spark markets itself as a fast and unified analytics engine for big data and machine learning. And big data in this case is anything that can't fit on a single machine. Machine capabilities are getting bigger every day, but of course so is the data that we're processing. And so we're talking about data that can't fit on your local machine, can't fit on a single EC2 instance. You're going to have data spread across different sources, different files, different servers, and this is how you're going to need to be able to read that and do processing on that data in a way that makes sense, and Spark is a really useful tool for doing that. Spark is generally thought of as an improvement on top of Hadoop and MapReduce. In fact, it was built on top of Hadoop and MapReduce. And depending on what you're doing with it, it can be up to 100 times faster than doing the same thing in Hadoop, which is pretty impressive and one of the big reasons that a lot of people have moved to this project. One of the major benefits of Spark is that it has built-in support for multiple languages and frameworks. And so you can see here that it has support for Scala and Java and Python, but it also has these frameworks on top of it for doing things like streaming data and machine learning. And it's really been promoting its machine learning capabilities lately. But as my friend Ryan likes to say, machine learning is just that carrot that you dangle in front of data engineers to get them to do the actual data engineering. And I think it's really good that Spark provides the ecosystem to do both things, because that's going to make your team more effective in doing the machine learning down the line, because you're still going to be working within the same framework, within the same type of project ecosystem. And that's going to make you a lot more capable to get the data in a state that you can do the fun, more interesting analysis on. On the data engineering side of things, Spark has two main abstractions that we'll use. And we started out with RDDs, or resilient distributed data sets. And those are not going away, but for a couple of reasons, people are moving more towards the data frames now. And so data frames or data sets are a better option for a few reasons. Completely unrelatedly, I just always have to point this out, that it drives me insane that the camel casing is inconsistent on these. That is not a typo. Hopefully your IDE will catch that for you, but in the meantime, you definitely have to remember that, because it will drive you insane if you're anything like me. So a little bit more about RDDs. They are immutable and distributed collections on distributed data. They work really well with unstructured data. So if you have giant log streams that have no structure to them, RDDs are a good option for processing that. And they have a very functional API that's going to be familiar to a lot of Scala developers. If you've ever worked with Scala extensively, the API for Spark on top of RDDs looks very, very similar, and it provides a very familiar mapping and reducing interface that you will be familiar with from working with the collections library in Scala. And you can see how it's used in this code example to do a basic word count. Of course, as Holden likes to say, this is a data talk, so it has to include a word count example. RDDs are not going away. They still have their uses. But there were some problems with RDDs and problems with the initial iterations of Spark in the 1.x days. And early on, we discovered that users of RDDs were doing some unintentionally bad things. And one of those things that people were doing was using this method called group by key. And so this is a best practices guide that was written by Databricks. And if you're not familiar, Databricks is the company that provides managed services for running Spark. The creators of the Spark project started the Databricks company, and so in many ways they are the thought leaders, they are the source of truth for all of the things that you would want to know about Spark. And so if they're publishing a best practices guide, you definitely want to listen to them. And so it's interesting that they're telling you to avoid an API that was provided in the language. Group by key sounds like something that would be very useful to you. It sounds like something that you would need if you're doing any kind of data transformations, if you're doing anything that involves counting, aggregation. Group by key, especially if you're using an IDE, it's a function that may pop up as an option, and you're like, okay, that sounds kind of nifty, but it turns out that this is terribly unperformant. It's really, really slow, and people weren't sure why their code was performing in this way, and so they had to tell people to stop using this, and that there were better options available to them that weren't necessarily that discoverable. So fortunately, the project was aware of this, and they were actively working on better ways to make this more accessible to people, to give them tools that didn't have the same kind of pitfalls that you would have with something like this. And that's sort of how we ended up with data sets and data frames. And so Spark started by creating the data frames API. Data frames are going to be incredibly similar to something like data frames in Python or R, if you've worked with anything like that. They're a lot like tables. If you've ever worked with CSV files, they resemble that kind of structure very similarly. Because they come with a structure, they come with a schema, data frames and data sets require that you have a schema and semi-structured or structured data. And because of that, there's a lot of performance improvements that the API can make on top of your data for making querying it much faster. Data sets specifically are available in Java and Scala as a strongly typed option on top of data frames. And so as Scala programmers and as people who like to enforce our data and enforce our schemas with types, data sets are a way that you can do that with Spark. And because data sets effectively require a schema, they're about 2 times faster than if you're doing anything with RDDs. So if you're working with any kind of structured data, you definitely want to use this route. I think the SQL DSL, which I'm going to show extensively later, is one of the best things about this, is that it allows you to work with your data in a very familiar way of querying data using a SQL-like syntax. So you'll remember this diagram, this ecosystem, and the fact that Spark is supported by many languages, including languages like R and Python. But I do want to point out that Scala still has the most robust language API. And I'm not just saying that to make you feel better. I know we like to think of ourselves as the best, but Scala still has the best API for the language because it's just been built out more. The original Spark project was written in Scala, and so that's one of the big reasons that they put more investment into this API. And if you ever need to look at anything under the hood, you're going to be looking at Scala code, and so I think there's major benefits to being able to write Scala on top of Spark. Also, Scala has these strongly typed data sets, which is something that's just not going to be a thing in something like Python. So I think there's a few advantages that we still have for Scala on top of a language like Python. One of the big disadvantages early on, though, was that Python was just so much slower than Scala. And so you can see here when we only had RDDs as an option for abstractions, RDDs were about half as fast as Scala, and because of that, a lot of teams were learning Scala just to use Spark, because there was huge performance improvements you could get just from switching to Scala, and instead of having to learn how to be a Spark performance optimizer, which if you can avoid it, you don't want to have to do Spark engine optimization tuning as much as possible. But as you can see, once data frames came around, the execution engine is the same for all of these. There's a translation layer that makes the code execution under the hood use the same engine. And so the actual performance of data frames is very, very similar across all of the different languages. And I think this is going to be really interesting as we watch Scala and Spark and Python and the data communities in those different languages progress in the near future. So this tweet was in reference to improving accessibility for data scientists in Scala. And I think he really hits it on the head here, which is that Python and R already have very robust communities for data processing. I think the entry point to Python and R is a lot gentler than it is for Scala often. And so you find a lot of people who are academics, PhD students, bioinformatics researchers that are using languages like Python and R to do analysis of lab data or something like that. And they don't skip straight to Scala because there's already packages available like NumPy and SciPy that they can use to do their analysis. And I think Scala currently is lacking a lot of those resources. And so especially with the performance improvements with Spark and Python recently, I'm really interested to see how the community kind of reacts to this, and if there's more attention that's put on the Python APIs to get that up to par with Scala. So I definitely think that's something to watch out for in the next year or two. So that's some of the basics of Spark and where we're at with the project today. I wanted to spend just a couple of minutes talking about the state of passwords so we can understand where we're coming from when we start looking at the data. Like I mentioned, I think I spent a lot of time thinking about authentication, and we have a big problem when it comes to passwords. And that's that people reuse passwords, and they use passwords that are short and very easy to guess, and then they can guess those passwords and hack into my Netflix account. And it's problematic because even if you don't care if your Netflix account gets hacked, if you're using, or if I was using the same password there as I was for my email account or my bank account, you're going to have a bad time. And that's because hackers like this guy, and you know he's legit, because on top of all that encrypted mess, he got the word hacked to show up. I think that's really impressive. And he's got the beanie and the menacing smile. I definitely recommend Googling stock photos of hackers. It's a good time. But scary hackers like this guy can steal or buy your passwords from hacked websites, and they can use those in a process called credential stuffing to try to get access to your financial information, to your email, to purchase very expensive Apple products on your iCloud account, all that kind of fun stuff that's going to inconvenience you or lose you a lot of money. And so you might hope that people don't do this, that people don't have passwords as stupid as 1, 2, 3, 4, 5, 6, that they don't write it on a sticky note, but of course they do. And so we happen to know that this password, 123456, has been seen over 20 million times in data breaches. And this is according to a website called Have I Been Owned? How many people have heard of this website? So this is a really cool website that you can go to, and you can put in your email address or a password that you use and see if this has shown up in a data breach. And so this is very informative for you, because if this has happened, you know you need to change that password. You know that you need to potentially use different passwords on other websites if you were using that same pair of credentials for other websites that were not only like your LinkedIn account, which got hacked, your MySpace account, which got hacked, every account which has basically been hacked. You probably want to keep track of this. You can subscribe to this website and see if your email ever shows up in a data breach. And so this comes from a security researcher named Troy Hunt. He is an Australian guy that works for Microsoft, that rides a jet ski to work. I don't understand his life. But anyway, he has access to all of these millions and millions of credentials, and he makes them available for people to peruse. And this is the data that we're going to be looking at today. And so all of this data is also available for download. And so there's, like I said, a lot of these passwords that we can look at. And so I downloaded all that data, and we're going to take a look at that now. Cool. So what I have here is a Apache Zeppelin notebook. Has anybody worked with Zeppelin? A couple of people. How about Databricks? Has anybody worked with Databricks? Zeppelin is kind of like an open source Databricks. It's a free project that allows you to run Apache Spark from the interface, and it has a Spark interpreter built into the interface. And so you don't have to do as much setup as you would if you were running this directly on your local machine from a shell or something like that. And so I like Zeppelin because it allows me to show off the code that I'm going to be doing, and it also provides that built-in Spark interpreter. If you can see this, I'm just running this on my local host. And so I'm going to be looking at these passwords, and the first thing that we have to do is read in the password data. And so we can do this using the built-in Spark interpreter. Spark has built-in readers for CSVs, for JSON, for a few other things. So we can go ahead and look at the schema of this data. And we'll see that this is coming back with about 3 columns. Those have kind of weird names, and so we want to go ahead and get the column names for those, which we can conveniently do by setting the option to tell this that we want it to read the header. And so those have more interesting headers now. So we've got a password, a hash, and a count. But one other thing that I want to do is make that count not be a string so that we can sort by it. And we can do that by forcing it to infer the schema. And once we do that, we'll have a more useful set of password data. So before I show this to you, though, I do want to do one more thing. And that's take out some of these passwords. And so it turns out that people put a lot of really bad words in their passwords. And this is a professional setting, and so I don't want to expose those to you. And so I have a text file that you are not going to see. And we'll go ahead and join these together. And so what we want to do is join our passwords with our bad words on the value column. So we want to make sure that the password, if the password contains our bad words value column. Value is the default column name that it will give to a data set. And because we're reading this in and this only has 1 column, that's what it will be. And the very important thing is that we want this to be a left anti-join so that we're not, so that we're excluding these from the data set. And so let's go ahead and count these. So actually, let's do this before we join that. So let's go ahead and count those. OK, so there's 67 bad words, and there's about 700,000 passwords. And if we join these together, what do we get? Just want to make sure that we're not including the bad things in here. OK, so we got rid of about 200 or 20,000 at least the bad words, passwords in here. So that's good for you to know. So anyway, now that we have this, I can go ahead and sort this. We want to do this by the most popular passwords, and so we'll do that by a descending count. This is the SQL-like DSL that Spark provides with Spark SQL. And then it also provides this built-in show function, which I think is pretty nifty. And so this is what the data looks like. You can see the most popular passwords, things like 1, 2, 3, 4, 5, 6. the word QWERTY, I love you is up there. That's nice, but don't use it as your password. So as you can see, these are like, people start to think that they're getting clever down here. They're like, oh, maybe if I like mix in the letters with the numbers, nobody will know. But you're not actually as clever as you think you are, so just keep that in mind. So we can see the most popular passwords. Oh, dragon, I like that. I wonder if Game of Thrones had anything to do with that. So what we can do now is we can start to do some different type of analysis on our passwords. And so I want to look at what the most common lengths of passwords are, and that's not in our data set, but we can use some built-in functionality of Spark to get that information. And so we'll go ahead and add a column to our data, and so we're going to call that the length column. I'm going to go ahead and use the built-in length operator from Spark SQL to look at the length of our password column. And so once we have that, one of the really cool things that we can do is go ahead and run raw SQL on top of our data frame. And this is built into Zeppelin. Spark comes with different interpreters, but inside of Zeppelin you can say, hey, I want to change this up. I want to run raw SQL now instead of running the default Scala and Spark interpreter. And so you can write your SQL query. You can do like you would with just raw SQL. And we're going to be selecting from our passwords, and then we'll group by and order by our length. And I did not save this as a temporary table, so we do need to create a temporary view so that Spark can index this. And we'll go ahead and name that password. Sorry, that's a little cut off. So I can rerun this, and this will create a temporary view that then the SQL interpreter can read from. And now we'll be able to run this and get some information back about the most common password lengths. And so one of the cool things about Zeppelin is now you have the table view, but you also have some of these other built-in views. I don't really like pie charts, but this bar chart is pretty useful for getting some information about the most common lengths of passwords. You can see that they're clustered around like the short semi-minimums that we generally see in password input fields, like your password must be at least 6 characters long. Side note, the only thing that makes your password more secure is generally just make it longer. So password minimums of 6 characters, like almost all of those have been owned. There's only so many options that you can have with a 6-character password. So you can see that there's 289 million passwords in this like truncated data set that I'm using for this presentation that have been owned. So that's pretty interesting. One of the other cool things is you can start to do, you can do where clauses in here. So you could do where password, like, if we wanted to say like Scala. And then one of the very nifty things about Zeppelin specifically is then you can start to do variable replacement in here. And so you can go ahead and do something like that, like you would with a variable in Scala, and then you have this field that comes up, and so then you can go ahead and change this to be, if you wanted to see if New York had ever showed up in here, you can start to edit that, and then you can use this as a dashboard and hand it off to people that maybe don't even know SQL, or management that doesn't want to write SQL, or people that are the business analysts that maybe you're starting to see there's a lot of options here for making this type of data accessible, and that's one of the things that I really, really appreciate about Spark is that it has all these different ways for people to start using the same tool to read your data and to gain insights from your data based on the tool set that they know. And so I really love that feature about Spark SQL and how you can run the raw SQL on top of it, do the variable replacement in Zeppelin. There's a lot of cool stuff that you can do with that. But one of the more interesting things about looking at password is looking at the actual contents of the passwords themselves. And I think proper nouns are generally a good place for us to start with that. And so there's different approaches you could take with that. You could do famous people or geographic areas. I'm going to look at dog names. And so I have a JSON file that has some dog names in it. I'm going to go ahead and read that in, and we'll show the schema for that. So this JSON file has two columns that it inferred, and so I can go ahead and look at this. And if I want to go ahead and edit this, one of the really cool things about the schema inference is that if I give Max here a favorite food, and if I say his favorite food is chicken, and I go ahead and save that file, Spark does expect that JSON files are a single line per JSON, and so it won't read pretty printed JSON. But if I go ahead and rerun that and print the schema, even though only one column had, or one row entry had that variable in it, it will still infer that that's a nullable column that's now available in your data set. And so, this data set that I'm using is a very small JSON file, but you can imagine if you've got millions and millions of lines of log files, if you're using schema inference on those, you can gain a lot of insights into what your data looks like if there's new columns that appear, if there's columns that all of a sudden disappear that you no longer have to keep track of. There's some really useful stuff that Spark can do for you there to do the schema inference so that you don't have to keep track of what all of your data looks like, because I know if your data is anything like the data I've had to deal with, it's terribly unpredictable. So let's go ahead and see how many people use dog names in their passwords. Let's go ahead and join those together. So we can join the dogs with the passwords. And this is going to be something similar to what we were doing before. And so if we see like the password column, if that contains our dog name, and we will default to this being an inner join on this case, and so we can order by descending count. And in this case, I'm going to select only the columns that I care about, which is the name, the count, and we'll throw in the password. And so now what we can do is go ahead and show this. And so you can see that Charlie is a very popular dog amongst its passwording owners. And there's over 15,000 Charlies that have been seen in password data breaches. But one of the other things that you can do is you can start to manipulate your data to do some normalization on top of it. And so if you wanted to write a normalized function, you could use this doing the built-in Udf operator. And so this is a little bit like Scala definition syntax, a little stranger though. And so what you'll do is, so this is a user-defined function in SQL, and this will translate on top of Spark SQL to do a lot of operations and transformations for you that maybe aren't available as built-in functions like something like length was. And so in our case, we're just going to call to lowercase on this. And now what we can do, though, is we can go ahead and say, we'll normalize this password and this password, or this name. And so then if we run this again, we'll see a lot more data come back because we're starting to look at data that's no longer case sensitive. And so once we add that functionality in, all of a sudden the amount of owned Charlies in passwords goes up to 278,000 passwords that we've seen. All right, I'm going to stop there and jump back into the presentation. We can wrap it up. I think if we've learned anything from this so far, it's that we shouldn't use dog names and passwords as much as we may love our puppies. I think it's probably not the best way for you to start securing your online identities because, again, it goes back to something that's really easy to guess. Using the suffix 123 is incredibly common. You can see that by looking at the data. And that's one of the reasons that all of those password managers or password input forms that are like, oh, and you have to require a numeric character is really stupid because people use the same numeric characters in all of their stuff. It's like 123, one exclamation point, admit it, you've done it. If you're not using a password manager, we're all falling back to the same tropes. But some of the things that I think we've noticed about benefits of Spark include the fact that Spark is incredibly fast, it's really flexible, and it gets you up and running and a lot of insights very quickly. And I think one of the things that might not have come across as much in this presentation, but is a definite benefit of Spark is that it is proven for large systems. There are very large companies that are using Spark to do a lot of analysis. Twilio uses a lot of Spark internally to do our data analysis, to do fraud detection and other things around detecting call drops and that kind of things. So there's a lot of use cases for Spark at really, really large scale, and it's just as easy to use once you get it up and running as it is on 100 megabytes of data as it is 100 terabytes of data. Of course, Spark is not without its challenges. I think one of the things that we run into often is that there are very opaque error messages that come up with Spark, especially if you're using any of the interpreters outside of Scala. The error messages get wrapped in JVM stack traces, and so if you're using this Python interpreter, you're going to get like JVM stack traces wrapped in Python error messages, wrapped in JVM, it's a nightmare. And the error messages are getting better every day, but it's still something that can be pretty confusing to look at for the first time and track down, especially if you're running something on a lot of different nodes and maybe there was only a failure on one of your worker nodes, and you might not be able to track that down very easily. Operationalizing this stuff can be challenging. I included a link on this page and again at the end of this notebook about how to deploy Spark on a cluster, which Heather Miller wrote a couple months ago. There's a really good overview of how to do a lot of this stuff if you want to do it at scale. Everything I just showed you is running on my local machine for the sake of making sure that the demo works in front of an audience, but obviously that's not what you're going to be using Spark for most of the time, and so if you want to get this up and running on top of a cluster, there is documentation for how to do that, but it's something that didn't really exist until a couple months ago, and so you might have some challenges there. And finally, the documentation could use some work. There are some documents out there that are getting updated and have a lot of maybe unofficial documentation that are still like the go-to documentation now that I'll point out. So this is an example of a stack trace. So this is, I was trying to join something, and this was just on my local machine, and there was really long stack trace, and it goes on for a couple hundred lines, and it's really hard to tell what the actual problem was here. But this is the example of some of the very opaque error messages that you will see. In terms of the missing Spark documentation, the Spark docs themselves, I think, are low on examples. I'm definitely somebody that learns a lot by example code. But Yatsek here has written the Mastering Apache Spark and the Mastering Apache Spark SQL guides, which really, in my opinion, are the missing Spark documentation. And if you're somebody that is in the Spark ecosystem a lot, definitely bookmark this because you'll find a lot of great examples, a lot of great how-tos for getting around the project that you might not find in the official documentation. Wrapping up, I want to leave you thinking about some of the implications of big data and security. It's a useful tool for finding vulnerabilities, for discovering fraud in your systems, but as much as you can use it for gaining insights about your data, you could also be setting yourself up to be the next data breach. Data privacy is on everybody's mind. I think especially with GDPR that just happened, there's a lot of people that have been thinking about this nonstop for the last 6 months. There's a new data breach that happens every day with Cambridge Analytica and all the data privacy issues. Like, people are really thinking about this more now than ever. And as much as big data is a useful tool, we want to be mindful of the way that we store our data and how you have access to it and what data you are storing. I think it's very easy for us to say, we want to store everything because maybe we'll need it for analytics, like maybe this will be a useful parameter for our machine learning model. But honestly, like, the more data that you're storing, the more there is potential for that to be compromised. And I think that every additional piece of personal information that you store, especially, is setting yourself up for a lot more risk. Especially because nobody's security is perfect. As much as you might invest in your security in terms of your OPSEC, your InfoSec, your whatever sec, if you have any influence over the security at your company, including and especially if your company is too small to have a dedicated security team, make sure you're storing your passwords in a safe and smart way. Don't roll your own crypto. Use somebody else's crypto library. There are several that are very well proven in Java. I know we hate Java libraries, but use the Java crypto libraries. They've been around for decades, and they can help you out. So be the security advocate at your company because all of that password data that we looked at was available because those passwords got hacked and they were stored in a way that made it easy to back them out or to see them in plain text in a way that they're accessible. So this tweet, if you haven't seen it, was from a T-Mobile Australia. It was discovered that T-Mobile, or at least the Austria branch, was storing passwords in plain text, and unfortunately the support agent really doubled down on the impossibility of that being a problem, which I think as engineers, we know that these things aren't perfect, that nobody's security is perfect, but don't be like Kath. So that's kind of from the company side of things. I hope I'm preaching to the choir here. By the way, this guy, he's got gloves and sunglasses, and there's like money on the keyboard. He's up to something good. So as a consumer, the best things that you can do for yourself, use a password manager. These will generate long and random and unique passwords for the sites that you visit so that even if one is compromised, you won't have the vulnerability. You're not opening yourself up to the kind of credential stuffing that we would see with insecure or short passwords, and turning on two-factor authentication wherever it's possible. These two things alone will do a lot to secure your online identity. Security through obscurity, like most of you are probably not going to be the targets of hackers unless you're like tweeting about the fact that you have 100 Bitcoin in Coinbase. Don't do that. So one of the things that I like to talk about is my dad uses a password protected Excel spreadsheet to store his passwords. I mean, it's kind of funny, but like honestly, I'm pretty proud of him because the important thing there is that there's a security mindset there. He has an inventory of what his passwords are, and he's thinking about it. He's trying to be more secure, and nobody's going to break into my dad's, house and try to look at his stuff probably. And so for him, that's probably a good enough solution. I'll get him on LastPass eventually, but I think the security mindset is there, and that's often the biggest hurdle that people need to overcome in order to start getting into some of these security practices. So thank you for letting me spend some time with you, diving into Spark, especially through the lens of own passwords. I love chatting about this stuff, so if you want to keep talking or have any ideas for me, hopefully I've inspired some of you to dig into your own data with Spark. I don't even know with this one, like there's a wig and a skeleton, but the hands are normal. And I think she's like drinking tea. Anyway, this is like my alter ego, I think. So if you have big data, I think Spark and especially Spark SQL are really great tools for doing that analysis and for getting your team on the same page in terms of the tools that you use to digest, transform, and analyze the big data that you have. I will post these slides after this presentation, and I have a tutorial for all of this that, fingers crossed, will be posted on the blog, our Twilio blog next week. Come find me after this if you have any questions about Scala, Spark, or security. Once again, my name is Kelley Robinson, and thank you for listening. If there's any questions, we have a mic.
I'm just actually really curious because there are way more than I was expecting. The passwords had Scala in them. Could you mind showing the most popular ones of that real quick?
So we want to see the passwords that have Scala in them?
Not for personal worry, of course, right?
I mean, so we can look at... So a lot of those were like 8 characters, and so I'm wondering if it's like scalable that's in it. Escalade.
Okay.
I guess a lot of people want to put their cars in their passwords. Scalawag. John Pretty, is that you?
All right, 400 Scala developers that need to change their password.
Yeah, shame on all of you.